Hello everyone, welcome to Knowledge Optimizer. I'm Rajat and today we are going to start with a basic system design principle, that is separation of concerns. So we are starting this new series in which we are going to discuss about we are going to cover many different system design principles. So this is the one which we are starting with. So from the name only you can suggest like we are doing some kind of separation on the basis of concerns. So that's the actual idea behind this pattern only. So what does we mean by that is basically we divide a system on the basis of like what are the responsibilities, what are the aspect it has to perform. So the basic definition of it is dividing system into sections. The important thing to mention, keep this is distinct. So that's the idea of separation of concerns. Dividing system into distinct sections which are responsible for addressing responsible for addressing a specific concern or task or aspect. So to explain the same with an example, suppose you are building an organization. Okay, so let's see from the higher level what the structure of organization look like. So first of all you'll divide different teams. Okay, you will create there would be a business team, no landing WS. There would be a business team, there would be a tech team which will take care of this will take care of business tasks. So so what kind of business tasks basically like there could be multiple business, right? Like how the company will going to perform in the near future, what are the businesses where we have to do the investment, how we have to plan, all those things will be done by this team. Okay, now there would be a tech team that would be building different feature for different users, or how we can basically engage the users. All those things would be part of tech team. Like I'm including the product team also in the tech team. Basically product team reside in between those two, so it takes the business thing and provide it to the tech team. So just taking the product also here only. Okay, in the tech team. Then there would be an HR team which basically take care of or like manages people, like how people are performing, how people management, how people are performing in the organization, how we can make the workplace better. All those tasks would be done by HR team. Now we can further devise. So yeah, here only at the higher level only you can see like there are different responsibility. On the basis of different responsibility we are creating different team. So has it be okay, we'll come to that later. So let's divide further. Tech team will be further divided into two or three parts. Okay, there would be a product team, there would be a, or let's ignore the product team for now, there would be a dev team, there would be a QA team, there would be a security team, there would be a data science or data analysis team, DS team, for analyzing everything. Then now these teams are further divided into those many parts. Basically each team has a single responsibility. So, basically this is not like dev team will do all the development, the QA team will do all the QA part, security team will do all the security part, DS team will, data science team will do all the data science tasks. Now dev team can further be divided into manager, then senior devs, then devs, then junior devs. Basically now we know like these manager will just manage the people, now these will design those tasks, now this will do something else, this junior task will do something else. Okay, so we can now further, okay, consider an example. Like if we haven't done it this way, if we haven't divided the team on the basis of responsibility. Now suppose we are building a system Now we realize, okay, in our organization we need some people, but we don't know what kind of people we need, right? If we haven't hadn't decided in the team. Now if we want to hire a new guy, then for what purpose we want to hire them? We know, like, we want to hire a new guy, there is a need, but for what we want to hire? That's basically the advantage. Like, basically, now no, okay, there is a need in the business team, basically we want some business person. Now there is a team need in tech team. Now in the tech team also, whether you want to hire a QA or dev, basically those separation of responsibility, separation of concerns come here also, in the higher level also, in the real world also. Okay. Now and yeah, every team or every section which we have decided have a single responsibility to perform. QA will perform QA tasks, dev will perform dev tasks, tech team will perform tech tasks only, third team will perform HR tasks only, managing people, business team will perform business tasks only. Now coming to, okay, now suppose you have built a system. Okay, now in the system only there would be a UI part. Okay, UI UX part. Now there would be a whenever you are building a system, then there would be a backend part. Backend you have to implement. Then there would be, even in some cases, there's a security part also. You can ignore it. Okay, let's just we are building. There would be two parts. Okay, a backend team. Then there would be a UI UX team. Now in the backend also, we can further divide our system on the basis of, like, whether, okay, suppose you are building an e-commerce website. Okay, in the backend you are building an e-commerce website. Now UI UX team are building some kind of front end for that. Okay, there would be further, there would be revision on that. Let's just focus on backend. Okay, for now. So in the backend only, so suppose we want to make some, we want to create a user section, then it will go, there would be a user section, your user microservices for that. Now there would be, like, we want to make some change in catalog changes we want to do, or product addition changes, something of that type. Then in that case there would be a different services, product service or catalog service for managing all the catalog information. Then there would be a security service for managing all the security tasks, like this user is validated or not, whether it has access to these services, product catalog services. So this is where this separation of concerns comes into picture. Okay, so we'll discuss in detail about these, like how this is separation of concerns principle is helpful in HLD. Okay, now let's move to first of all, what are the basic, why this separation of concerns is actually that important. So you might have heard of so yeah, from the last example you have seen, like, if I don't know, whenever I have to hire a person, if I don't know whether I have to hire for a, okay, I know there is a need for one person in the tech team, like, but I want to hire it for dev or QA or something else, how I'm going to decide? That would be decided on the basis of this. Basically we have to separate all the teams in such a way to get the idea, to decrease the complexity, basically. Now I know, now I know exactly in which team there is a need for, whether I want to hire a dev, whether I want to hire a Q. On the basis of that, the interviews will also be performed on the basis of that only. So this basically help in making system less complex. Basically there would be a separate blocks, separate, you can consider microservices. Now you want to basic now, okay, now since you have divided them in such a way, now you know, okay, this microservice perform this task only. Okay, now the, so there would be this microservices 1, there would be microservice 2, there would be microservice 3. Now microservices interact with an API or with any system call. Now for this microservices, this is a black box. Okay, this performs some task. Similarly, if it calls M3, or then M3 is a block for a black box for M2. So that's how, like, now since a user want to interact with catalog service, now there would be an authentication service in between. Okay, even in some cases people combine this users with authentication service, but for use case, let's consider we have an authentication M2 microservice for that, M1 for user, and then M3. M3 for catalog. Now till then it does not cross this, it can never reach here. Okay, so you can see like we have separated all these dependencies, not dependency, I'll say all these we have isolated the blocks which are not dependent on each other. So that's why basically this reduce the complexity. Scalability is easy. Now suppose like there's a huge traffic. Okay, there's a huge traffic on this user service. There would be multiple non-login users would also be there. Okay, but you don't want them to place order. Okay, but they can't place order obviously till they are not logged into this service. So obviously the traffic would be very less here. Okay, whereas the traffic would be very high. Now you can scale this service, you can run 20 pods of this service while running the 5 pods only for this service. Has it been like you have created a single system with all the code changes, then in that case you might have to increase the 20 pods for this. You will increase the 24 for this whole, we usually call this monolith. Okay, all the code everything we are keeping in just a single services, in a single service. Then you have to run the 20 pods of this service while there was no need for increasing the pods for M2 and M3. You are just wasting your resources. So this is helpful in make even decreasing the cost of your service. Now in some cases it also lead to increase the cost. We'll come to that later. Okay, we'll see that with an example. Now uh, now maintainability is very easy. How is this easy? Now okay, there would be a specific users. You can actually even assign some of the, you might have seen in your organization, like you are assigning some kind of services to a single user or group of user. Now this team, basically we have further divided the teams on the basis of like who are going to own which service. Now the responsibility is divided. Okay, now some user, basically team 1 will look after this service, team 2 will look after this service, team 3 will look after this service. Has it been single, again like there would be 50 60 users would be working on that. And there would also be a problem, like now we can do parallel development. Okay, but has it been a single system, there would be multiple user performing that. Now there would be a dependency created on basically this M1, this whole project. Basically a dependency would be created, like user 1 will do the change in here, then till then all other user will be blocked. While in this case, like one user can work on this service, basically do the development, while other users, basically if there is a development which required the changes all three microservices, then different set of users for different user basically do the parallel development here. Now since they both are independent of each other, you'll just do the development here, you'll just do the development here. Now till when you have to do the integration, you can also do the single testing of these microservices with different unit tests. But when you have to perform the integration test, then only you will require the other users to complete with the development. So you can see like even the development is very fast, we can do parallel development here. And also coming to reusability, obviously reusability will be very less. So suppose okay mm, so suppose like what do I mean by reusability? Suppose you have created a system, you have created a monolith M1. Okay, now there's another system which requires some part, which requires some part of this service microservice, sorry, this monolith. Okay, this is also a monolith. Now this requires some part of this monolith, and so it won't interact, obviously it won't interact with it. It will create a, it will write its own code of chunk for that. That would be same code which is kept here. So in this case what we can do is basically we can divide them into, this code is same, but we have to write it, basically the logic will be duplicated in at both the places. So that's why this microservices structure come into picture. Now we divide this into three blocks and they both can reuse it. So library is a very good example. If you have used any Apache library or if you have created in your organization some library, so those are very good example of this. So we have created a separate code which is performing a single task in an isolated place. Now you can reuse it with updating the text. Now we'll see like how SOC, separation of concerns, is applied in software development. So maybe you might have heard of, if you have heard of software architecture. Okay. Now there is this layered architecture where we have this presentation. If you are aware, present we basically define presentation layer, then business layer, then data access layer. So this is obviously, now we what we are doing here also we are doing separation of concerns, then here also we are doing. Now when we move from monolith to basically microservice architecture, the main idea behind here also is basically separating whole system or dividing whole system in different microservices, and each microservices will perform a single task. And the main idea when you are dealing with the microservices, you will see the database also is separate, like there is no shared database. There could be chances when there is this over engineer, when you can see like they are going to be over engineered, then in that case we go with shared database, but that would be rarely we will do. So in for the that's the main idea of main thing of this microservices. There would be a different database, it will going to interact. Basically there is a this whole block, there would be a microservice, there would be different database for this. Similarly M2 microservice, there would be different. So it would be totally very separated. So that's the main idea when people start moving from monolith architecture to microservice architecture. Main idea when you are asked in interviews, so main idea is this only, like the reusability is one of the thing. Then there is this scalability, complexity, maintainability, parallel development we can do. Now coming to whenever you are giving any HLD interview, so you have to keep this thing in mind whenever you are designing like the how many microservices would be there. So you have to identify basically first of all the concerns. Like we took the example of e-commerce. Okay, now we know there would be a user service for all the user related tasks. Okay, now there would be then there would be a product service for all the catalog managing tasks. Then there would be a also security services for authentication and all other purposes. Now you have to basically keep that there could also be a shipping services or order services. Now in the product only, if I just further this catalog service, if I just I can further categorize this. Similarly the user service, I can further categorize this. Now if you want to create an offer system, there would be a different microservices, a set of microservices you will create. Further you will separate them, like in the if I give you an example of only whenever you want to provide any reward or apply any coupon, then there is a basically rule services, what are the rules going to apply. Then there would be a reward service, then there would be basically this offer service, then engagement services. It's just a part of, even you can divide this offer engine into four microservices. Similarly if you want to basically whenever you are working in an booking system. Okay, now the booking system, okay, first of all we started booking system. Okay, this is a single piece. Now it can further be divided into different microservices. Planning engine would be there, then there would be booking system, billing, pricing, all those things would be there. Okay, so whenever you are building any HLD or giving any HLD interview, then first of all you have to identify the concerns. Then only it would be easier for you to basically create different blocks of microservices which you will going to be required in that. Now these are all the advantages of going with this separate this design principle or this microservice architecture or other things. But there are cases like when this is even not that useful, when people start to do over engineering, like they want to separate everything, then in that case it will not beneficial. Okay, to give you an example, like in the recent I think 1 year back only, the Amazon Prime Video basically he moved back from microservices structure to monolith. So why they moved it? Okay, so earlier they have created different microservices. Okay, M1, M2, M3. Okay, M1, M2, M3. Now suppose there is a content come to microservices 1, this will going to perform some operation on that content. Now suppose there is this AWS cloud. Okay, S3 buckets here they have created on the AWS. Now they basically whatever content they get from S3, consider like there is an event came with the event information, S3 bucket name, and basically the video ID or something. Okay, file name basically. So like on this microservices there would be an event with file name and bucket name. Okay, now this microservice first microservices was doing, now first of all this microservices will fetch data from S3, from S3. Now suppose this is a microservice which perform the audio related task. Okay, okay, this microservice perform the audio related tasks. It tune the audio, or it basically do everything, every other task, okay, on the audio. Now it will further basically first of all it fetch the data, now push the data to S3, to S3. Now it will provide the data to basically microservices 2, basically trigger an event when post pushing the data to S3, it will trigger a further event to microservice 2. Now microservices will have file name and bucket name. Okay, now what this microservice is doing is basically getting the data from S3, getting data from S3. Now doing some processing on video, suppose this microservice is doing some video processing. Okay, now it will further push the data to S3, the same step, getting data, pushing data once the changes are made. Now this microservice further trigger an event to M3 microservice. Now it will do some, suppose some text analysis kind of thing, and text enhancement you can say. Okay, this microservice 3 is doing. Now it will further get the data from S3 and post processing push the data to S3. Even if now you can see, okay, now this is doing audio task, this is doing video processing, this is doing text part. Now consider like these two can be performed in parallel also, right? Yes, it can be performed. So suppose even since we just remove it from here, we just trigger an, whenever we trigger an event from wherever we can get, there will be a different three queues we have created. Okay, q1, q2, q3. Now these three will perform all the tasks in parallel. Okay, so still you can see what is happening. We are getting the data, we are pushing the data to S3, getting the data, pushing the data to S3, getting the data, pushing the data. Now there are three get call from S3, three put call from S3. Though we have optimized basically, though we have created different microservices on the basis of what task they are going to perform, but you can see if we kept it in one system instead of this, there would be one get call from S3 and there would be one put call from S3 to S3, sorry, right? So there are two extra calls we are making here. So now due to this, they realize the cost is very high for them. Basically they are adding two times, two, not even two, three times, basically they are making 3x calls, two extra calls. Okay, 2 or to 4 basically 4 extra calls they are making to S3 in case of this microservice structure. The cost came very high, then they basically decided to move back to monolith. So there is an interesting article here, you can even read about it. Amazon dumps microservices from video monitoring. Okay, they moved back for basically prime video processing, all those part, back to monolith architecture. So that was the main idea behind basically why they moved it. So you basically have to find the middle ground when you have to realize what is the cost, how the cost is going to be impacted. Now so far you have read like microservice structure will be helpful in basically decreasing the cost of the system, cause there would be a one system we want to scale, where we want to keep other two system at the same level, we don't want to scale them, then this is useful. But in such cases, like in these cases, now they have created a different microservice, they end up just increasing the cost of the system, though there was no need. So you have to find that balance basically. So I hope you got some idea on this system design principle. Let me know if you have any question about this, and you can just let me know in the comment section. And thank you all for joining. Please like, share, subscribe.